this is the second lecture of the today's lecture. In today's lecture, we will discuss analysis of algorithm, growth of function, and asymptotic notations. First of all, how to analyze the algorithm. We will see in the next slide. You can analyze the algorithm with the help of two terms. As I told you in the previous lecture, by finding the time complexity and space complexity, you can analyze the algorithms. Same I have mentioned here. First is time and second is space. Third is not required. Thus, analysis of algorithm is determination of the amount of time and space resources required to execute it. So, you have to find the time complexity and space complexity. For that, you need to understand the growth of function. There are three cases when you find the complexity, or there are some types of running time analysis. First is worst case, second is average case, and third is best case. I'm going to take an example of array. Suppose you have an array 1, 2, 4, 9, 12, and this array is already sorted. I said that use the selection sort and sort this array, but array is already sorted. It means there are minimum number of steps required to run the program. If array is already sorted, then you will take minimum number of steps to run this program. Suppose if array is not sorted, if you are taking minimum number of steps, then this is best case. But suppose your array is 12, 9, 4, 2 and 1. This is the reverse of above. Means you have to convert it into the increasing order. Means in each step you have to swap. So maximum number of steps it will take. This means this is the worst case. Right? But if array is in increasing order and in decreasing order, some in increasing, some elements are increasing order and some are in decreasing order, in that case this is the average case, because average number of steps required to run that program. So this is all about the types of running time analysis. Order the following function by their growth in increasing order. One more thing you need to understand in the previous. Suppose I said draw the graph for these cases. This is n. These are the number of steps. Right? This will be the worst case, because maximum number of steps. This is average case, because average number of steps we are taking, and this one is best case, because we are taking minimum number of steps to run that program or algorithm. This is the graph. Now we will see. You already have some functions and you have to find out their growth. This is already in increasing order, but I know this, you don't know. So how will you check that this is an increasing order? Because you don't know the value of log n, you don't know the value of n and log n to the power n. If I write 1, 2, 3, 4, then you already know the value, but in this case you don't know the value. So we will solve this with the help of this table. One, log n log n square 2 की power n, and next is factorial n. These are the function you have, right? And you have to take some value of n equal to 1, 2, 3, 4 and so on. And you will take some value n equal to 10, randomly n equal to 100. Why we are taking these values? You will see in the last of this slide. First of all, I will start from this log n. I will see this 1 later on. I put the value of n equal to 1, then log 1 is equal to 0 already know. And here n equal to 1, and this is 1 log 1. Log 1 की value 0, so it means 0. N square again 1, 2 की power 1 means 2, and factorial 1 means 1. Now see the next one, n equal to 2. This is log 2. And what is the value of log 2? There is some value of log 2, you will calculate it later on. Similarly this and same this, we are taking this 3 only. Later on I will see this. N square, 2 का square means 4. Again 2 की power 2, 4. Again factorial n, factorial 2 means 2. N equal to 3 if you are taking, then 3 is a 9, and 2 की power 3, 8, and factorial 3 it means 3 into 2 into 1, 6. If you are taking n equal to 4, then 4 का square 16, 2 की power 4, 16, and factorial 4, 24, right? Similarly, we will calculate all these values. Now we will see at n equal to 10. Log 10 की value क्या होती है? If I am taking log 10 base 2, then this is 3.32. Right? If we are taking base 2, then value will be different. Sorry, this is 2, base 2. If we are taking base 10, then this is 1. Right? Next is n equal to 10. Next is 10 into log 10 की वैल्यू हमारी क्या आई थी? 3.32. It means 30 point something आएगी. N square, 10 square means 100, and 2 की power 10, it's a large value, and again factorial 10, this is also a large value. You will calculate it on your own. Next is n equal to 100. You will calculate this yourself, right? What is the meaning of this table? Just see here. Value 1, 2, 1. Some is in increasing order and some is in decreasing order. In the next step, 4, 4, 2 in decreasing order, 9, 8, 6 means in decreasing order, 16, 16, 24, it's in increasing order. And in next one, you will calculate yourself if you want. If n equal to 10, then value is 3.32. Next is 10, 3.32 से बड़ी है. Next is 30 point something, that is also greater than 100, greater than previous one, and log n, and 2 की power 10 is also greater than n square, and factorial 10, this is greater as compared to 2 की power 10, means all are in increasing order. Right? It means if you are taking the value of n in it is very tough to find out the growth rate. But if you are taking large values, then you can easily find out the growth rate of any function. Means, suppose you have this question in your exam, then you have to calculate the value at least n equal to 10 and n equal to 100. Sometimes when we are taking n equal to 10, in that case you will find out the values at n equal to 100 also, right? Definitely you will find the increasing order. If you are not getting the increasing order, then according to this you will mention these function in increasing order. Means based on this and this, you will write the order of the function. In this way, you can solve any function, or you can find out the growth rate of any function. Maybe question n cube, maybe question is n log n square or n square log n. Then you have to identify the growth rate according to this solution. Means you have to find a solution for that. The growth of function. Now see the next one. Here there is a comparison of growth rate function. One more thing I didn't tell you. This one. If you are taking constant 1, 2, 3, 100, 1000, 10,000, then value is always 1. In that case, value will be 1. You taking any value. Here you have taken 1, here you have taken 2. In that case, value will be only 1. Right? This is also 1. You are taking n equal to 2. Now see the next one. Here I have written some of the value like log 10 base 2 is equal to 3. 3.32 approximately they have taken its 3 and so on. This is also one more example. Now see the graph of the previous solution. We are having these functions, right? You have calculated this value of factorial n, and the value of factorial n is highest, 3 lakh something, around 36 lakh or 3 lakh something. Yeah, you can calculate yourself. So this value is highest as compared to all of these values. So you will draw this like this, because this is worst case, maximum number of time or maximum number of steps, maximum value. Now next is 2 की power n. This is less as compared to this, so I have draw this like this one, and similarly n square and log n and log n 1 means minimum value we are taking at 1. Log n is greater as compared to this, so this will be the minimum value. In this way you can draw the graph also for the same function. Now we will see the performance measurements of all these asymptotic analysis. Means asymptotic analysis is used to analyze the performance of an algorithm for some large data set. We will see this in next slide with an example. Mainly you need to understand these terms, this term. This is the basic definition of asymptotic notation. Asymptotic notations are some mathematical tools to represent the complexity in terms of time and space, and that you are finding in big O notation, big omega notation. These are the types of asymptotic notation. Basically there are 3 types of asymptotic notation mainly, but totally there are 5. We will see the example of big O notation, big omega notation, theta notation. These are the main notation, and there are two notation more, that is small omega, small o. Now one by one we will see this. First is big O notation. Big O notation means upper bound. You understand this by the word upper bound, right? This is used to describe the asymptotic upper bound of an algorithm. Now you have a condition of big O notation. If Fn is less than equal to Cgn and greater than equal to 0, where C is constant and Fn and Gn are the functions, then we can say Fn is equal to big O Gn, and where n must be greater than n0. n0 is also a constant. You need to remember this condition only to solve the big O notation. Now in this graph, Cgn is a less value, so this will be on the upper side. Fn is a less value, means minimum number of steps, this will be the lower side. Suppose we are taking a function Fn equal to 2n plus 5. This function we are taking. Now you have to calculate the value of Gn, C and n0. Gn is a function, C and n0 are the constant. In what condition this Fn is equal to big O Gn? You have to satisfy this condition for this big O notation. Fn is equal to big O Gn if and only if function is less than equal to Cgn. This is the condition of big O notation, as I already told you in the previous slide. And this Fn is greater than equal to 0. This is by default, so no need to write this. Now n is greater than equal to n0. This C and this n0, these are the constants, right? And this Gn and Fn are the functions. Now I am taking C equal to 3. But why I have taken C equal to 3? Why didn't I take it 1, 2? Suppose I take C equal to 1. Then I will write it 2n plus 5 less than equal to 3, less than equal to Cn, because Gn equal to n. Why I write Gn equal to n? Because the highest power of this n, or highest coefficient, highest power of this n is equal to 1. It means Gn is equal to n. Suppose function is 3n square plus 2n plus 5. In that case, Gn is equal to n square. Means whatever the power of n, you have to take the highest power of Fn. The highest power of Fn is n square. That's why I have written it n square, Gn equal to n square. In this case, in this example, highest power of n is 1. So I have written Gn equal to n. Now I am writing it 2n plus 5 less than equal to 1n. 2n is obviously greater than 1n. So it means this condition is not possible. If I take C equal to 1, 2, 3, 4 and so on. At 1 this is not possible. Suppose I take this C equal to 2 and this is 2n plus 5. 2n already we have plus 5 more. And this is saying less than equal to 2n. So this is also not possible. But if I write it 3, then maybe any value of 1, it can be possible, because 3n is greater than 2n, right? So we have to check at 3, because this can be possible. Now according to this is the closest value. I have to write c equal to 3, and when we have n equal to 1, then 2 n की वैल्यू हम क्या रखेंगे 1 प्लस 5 लेस देन इक्वल टू 3 और n की वैल्यू हमने क्या रखी है 1, तो इट मीन्स 7 लेस देन इक्वल टू 3, कंडीशन फॉल्स. n equal to 2, again condition false. n equal to 3, you will calculate yourself. This is false. 4, this is again false. And at n equal to 5, condition is 15 less than equal to 15, it means true. So in that case you can write n equal to 5 and 0 is equal to 5. Suppose if I take n equal to 6, then condition will be true. If you take n equal to 7 and so on, means the value above 5 or equal to 5, then the result will be true. That's why we are taking it n greater than equal to 5 and c equal to 3. For these two values, fn is equal to big O n, we can say. I think this example is clear to you all. If you have any query, you can write down in the comments. Thank you everyone.